Today we will be discussing about biosafety guidelines and standards. So why do we need biosafety and biosecurity standards? So basically, the one of the main reasons why we need to implement these biosafety and biosecurity standards are to prevent laboratory-acquired infections. LAIs, or the laboratory-acquired infections, are significant causes. Is a significant cause for infections and outbreaks. A case in point, in 1978, in Birmingham, United Kingdom. So, a smallpox virus escaped from the Birmingham Medical School laboratory, leading to one fatality due to the cause was found out to be a laboratory mismanagement. So, just a brief background. By this time, smallpox was deemed eradicated through very rigorous vaccination of all people in the world, or at least all known people in the world. So that basically when you vaccinate, the idea is you vaccinate all of the people, therefore the smallpox virus won't have a host anymore, and then it will completely be lost, or there won't be any host for, since there are no host for the virus, it will be destroyed. So the only remaining sources of smallpox known today are in secure laboratories. And one of those laboratories is in Birmingham. And at that time, it is one of the samples being studied in Birmingham Medical School. However, due to a certain mismanagement, I think it passed through the ventilation system and it infected a photographer for the Birmingham Medical School. And so that person died. And so from then on, they established a very rigorous standards for biosafety and biosecurity. So another one was the 9/11 attack, leading to or followed by the anthrax attacks. So what happened back then, that was in 2001, there were a series of envelopes containing anthrax spores. So basically, it's the spores of the Bacillus anthracis. And it was mailed to members of the US Senate and some media outlets. It led to 22 infections and 5 fatalities. So, of course, it was a terrorist attack. And in their study, they found out that the spores were obtained from a sample, or rather, the spores came from the U.S. Army Medical Research Institute for Infectious Diseases. And it was actually an employee there who worked with the terrorists to steal samples of the spores for to send to the U.S. Senate members and to the media. So this basically an issue of biosecurity, where there is an intent. The first one about the smallpox escape, that was a biosafety concern because there was no intention. They do not want the smallpox to actually escape the lab, but it was due to mismanagement. But for the case of the second one, the anthrax attacks, so basically this is an issue of biosecurity because there was an intent. The bioterrorist wanted to incite fear and probably wanted to kill BIP politicians and the media. Well, basically the media is there to incite the fear. So there is an intent. So that's biosecurity. So in the Philippines, we have several institutions on biosafety. Actually, these are implementing bodies that audit laboratories for biosafety. So we have the National Committee on Biosafety in the Philippines, that's NCBP. This is a body under the OST. But if you look at their website and their regulations, they do most of the regulations on the research, manufacture, and the use of the GMO. And we have the WHO Biosafety Standards. We have the WHO headquarters, Philippine headquarters in UN Avenue, just beside the NBI. And then we have the Philippine Accreditation Bureau, PAB. Now, for the PAB, this one is mostly not only on biological laboratories, but on laboratories in general. And they are not solely on biosafety, but basically regulatory safety and, of course, accreditation in the laboratory. So the national accreditation body of the Philippines used to accredit inspection, testing, and certifying bodies and other bodies offering conformity assessment services. And then we also have the ISO IEC 17025 series of 2017. That's the latest one. This is a general requirements for the competence of testing and calibration laboratories. This one is for general chemical laboratory as well. So although the ISO IEC is rather than a governing body, it's basically a series of standards, protocols, and procedures that should be observed for a competent testing and calibration laboratory. So standard operating procedures. So the success of biosafety controls depends primarily on individual workers using controls as designed. So in the last week we discussed about the biosafety levels and the usual engineering controls, basically the infrastructure, the biosafety cabinets, and the PPEs used for biosafety. Now we are looking at standard SOPs, the procedures, the protocols. How do we actually use these engineering controls? How do we use these biosafety cabinets, the PPEs properly so that they will do their job as efficiently, or we maximize their efficiency? So, SOPs are instructional documents designed to guide different people doing one thing the same way and achieving the same outcome. So, it's also for quality control so that you get consistent results. So, it should be based on a robust risk assessment of the activities being conducted, the biological agents involved, and the specific primary and secondary engineering controls that are in place for the given facility. So, what are some examples of SOPs in biology laboratory? For example, what should be done when you enter or exit the laboratory? For example, it's BSL level 3. So, of course, you need to don the PPE. Do you need to take a shower first before entering, or do you need to take a shower after or before leaving the laboratory? And then donning and doffing your PPE devices. There is actually a certain order on how you take don or doff, that is put on or put off your PPE, because of course you can just randomly don or doff your PPE. There is an certain order to that so that you minimize contamination to yourself and to others. And then instruments. How do you actually operate the instruments? How you turn on the BSCs, etc. How do you use the biosafety cabinets? And then what should be the proper response during an emergency? For example, there's a fire in the laboratory. For example, since you're using alcohol lamps, your sleeve accidentally caught on fire. So what happens? So what should you do? You should not run around like a headless chicken in the laboratory shouting fire. So what should be done when that happens? And then proper hand washing. And then how do you do with the waste? So of course, these wastes are hazardous wastes. You just don't put all of them in a certain plastic bag and then put it on the waste basket. So there must be a proper segregation, management, and disposal of the waste. And of course, inventory control. This is for biosecurity so that you avoid theft of dangerous materials and infectious agents in the laboratory. And also, aside from that, there must be some standard operating procedures specific for certain analytical techniques or certain experimental activities or experiment-specific activities. So that's it for this part of the lecture. Thank you for listening.